Okay, so the last time we met, we started talking about three-dimensional figures, and we talked about classifying them in different ways. We talked about classifying them as spheres and prisms and pyramids and cones and cylinders and all those things. And we also talked about finding the surface area of those figures and how surface area is how much space the surfaces of a figure takes up. So if we were to cut all the surfaces of a figure apart and lay them out on a table, we would say how much space or how much area those surfaces all take up. So today we're going to talk about volume. And in your packet that I handed out to you guys, I've also uploaded the practice pages in case you don't have your packet. I've uploaded those into the assignments portion. But from our packet of notes, we are on page 6, and we're going to start talking about volume today. So page 6 in your packet. Also, this would be a good time to pause the video, and if you need to get all your materials, you probably want a pencil and a calculator as well as your packet. So if you would like to pause your video right now and get those things. So calculator will be very handy today. All right, so we're going to talk about the volume of these three-dimensional figures. Now, volume is what these objects can hold, what they can contain. So if you think about these figures as a container, as a box, or as a can, or whatever it is, then you're thinking about volume as how much can we put on the inside of it. So a lot of times we're thinking about filling it with liquid or air or something like that. So volume is how much these figures can actually contain. So we're going to start with probably something that you have found the volume of before, and that is a rectangular prism. And we learned that a rectangular prism who has all squares for their sides, that's called a cube. So it works the same way for cubes and rectangular prisms. And you've heard this formula for volume before. It's over here to the side, if I can get my highlighter. And that is volume is length times width times height. Volume is length times width times height. So I'm sure that we have all heard that with volume before. So to find the volume, we're going to do example 1. Of example 1, the volume of this rectangular prism is going to be the length times the width times the height. So the length of this figure, I'm going to say, is 17. The width is 9. And the height is 24. And since we are multiplying these, it really doesn't matter the order because multiplication is commutative, which means you can swap the order. And then I'm going to use my calculator to help me. 17 times 9 times 24. So please participate with me. Math is not a spectator sport. All right, when I multiply those three numbers, I'm getting 3,000. Sorry, I'm trying to use my pen. 3,672. Now, these have units, and units is important. So remember, for surface area, we use squared units. Well, for volume, we're going to use cubic units, and these are in centimeters. So it's going to be 3,672 cubic centimeters. So it's centimeters cubed. So that's how you do it for a rectangular prism. So I'm going to go through and try to give some examples of different kinds of figures. Let's skip down on the same page to number 4 and do it with this triangular prism. Now, for any other prism, volume is big B times the height. Now, we learned last time we met that big B is always the area of the base. So whatever shape your base is, you can use your formula sheet and find the area of the base. So this base is a triangle. It's a triangular base. So for this one, big B is going to be a triangle. So big B is 1/2 times base times height. That's how we find big B for number 4. So the base of that triangle is going to be 12. Because if you look at this triangle, the one on top and the one on bottom is the same. And the height of it is 7.3. So big B is going to be 1/2 of 12 times the height, which is 7.3. If you want to, you could go ahead and say 1/2 of 12 is 6. So it'd be 6 times 7.3. So my calculator, 6 times 7.3, I'm getting 43.8. So my area of my base is 43.8. That will be square feet. So for volume, remember we're big B, which is the area of the base, times the height. So we just found the big B to be 48 or 43.8 rather. And the height of the triangle, remember, is the distance between the bases. Well, the distance between the bases is this 5 because you see the triangles are kind of sitting on top of each other. That triangle's on top of the bottom one. And they're 5 feet apart. So 43.8 times 5. Use my calculator. And I'm getting, that comes out to be a nice whole number, 219. And volume is in cubic units. So this is going to be 219 cubic feet. All right, let's do number 6. Number 6 has a different base. The base on number 6 is actually a trapezoid. Okay, so the area of a trapezoid is 1/2 times the height times the quantity B1 plus B2. So I'm going to find that first. So I'm looking at this picture. I'm going to look at the front one. So this one's 36 as well. So my area of my base of my trapezoid is 1/2 times the height of the trapezoid is 17.9. And my short base for that trapezoid is at 14 down there. Plus the long base of that trapezoid is 36. So order of operations, I got to add 14 plus 36 first. And that's going to be 50. So 1/2 of 17.9 times 50. Well, I'm going to go ahead and do 1/2 of 50 is 25. So 25 times 17.9. Just less calculator punching that way. So I'm getting the area of that trapezoid is 447.5 square meters. So that's my big B. So for the volume of this prism, it's going to be my area of my base, which is 447.5 times the height. And remember, the height in this case is the distance between the two bases, which is going to be that 25 right there. So 447.5 times 25. So remember, the height that it's talking about is the distance between its bases. So I'm going to use my calculator, 447.5 times 25. I'm getting a big number, 11,187.5. And remember our units. This time it'll be cubic meters. Okay. So that is a volume of a prism. It's the area of the base times the height. All right, let's skip to cylinders. So now we're going to be on page 7. And we're going to skip down to cylinders and look at problem number 9 in our packet. Page 7, problem number 9. So the volume of a cylinder, remember the volume is how much the container will hold. So if you think about this of like a can of vegetables or a can of Coke or something like that, the volume is how much that cylinder will hold. So since cylinders have to do with circles, of course it has to do with pi. And actually the volume of a cylinder is pi r squared h. Well, anytime you see pi r squared, that refers to the area of the circle. Pi r squared is the area of a circle. So it's basically the area of the circle times the height of the cylinder. So that's pretty cool. So it's, you can just remember it's the area of the base times the height for most of the things, then that will get you pretty much volume every time. So it's pi r squared times the height. So we're just going to plug things in. On number 9, they gave us the radius. If they give us a diameter, remember we take half of that to get the radius. So my radius is 18. My height is 15. So my volume is pi times r squared, which is 18 squared, times the height is 15. Now, order of operations, we always want to do our square first before we multiply. So 18 squared is 324. Whoopsie. Times 15. Now, I'm going to type that in my calculator using the pi symbol. So remember, the pi symbol is on that rooftop key that's above the division key if you have a TI calculator. So I'm going to hit second rooftop, and that gives me a pi. If you don't have a calculator that has pi in it, then go ahead and use 3.4. And remember, we're going to be rounding these, so I'm going to use the approximately symbol, little squiggles. So pi times 324 times 15. And I'm getting that is approximately 15,268, and I'm going to round it to 0.1. And my units will be cubic inches. Okay, so if we're going to use pi, and we're going to round decimals, make sure you use the little squiggles. And if you don't have a calculator that has the pi symbol, then go ahead and use 3.4 and round it. That will be absolutely fine, since we're rounding anyway. All right, let's do an application problem. And you guys know that an application is just another word for a word problem. All right. So an application, let's do this number 11 here. It says a cylinder with a 2 centimeter diameter is drilled through the triangular prism shown on the left. So let's look at this picture over here. Zoom it in a little bit. All right. So think about it. You have a triangular prism with a cylinder drilled out of it. Okay. So it's like a pipe thing going on through the prism. Think about it. So there's a missing cylinder out of this triangular prism. All right. So we want to find out how much this triangular prism would basically hold if that cylinder part is taken out of it. Okay. So I know it's kind of hard to think about, but just think about it like that. So a cylinder is taken through a triangular prism shown on the left. Find the volume of the prism. All right, so basically what we need to do is find the original volume of the prism and then find the original volume of the cylinder, and then we can find the difference in those two by subtracting, and that will tell us how much volume is still left in the original triangular prism after we've taken out the cylinder. So that's what you basically need to do, is find the volume of both figures and then find the difference in those two volumes. So first, let's do it for the prism. Labeling your work really helps here. So that's a triangular prism. That looks like it's a right triangle on the top, which matters a bunch. So 1/2 base times height for the big B. So big B is 1/2 base times height, which is going to be 1/2 of 5 times 5. So B equals half of 25, which is going to be 12.5. So that's the area of big B. So we need to find the volume of that, which is going to be big base times the height. And the height of that triangular prism is 14 centimeters. So 12.5 times 14, using my calculator, I'm getting 175. So the total volume of that prism before anything is taken out of it is 175 cubic centimeters. Okay? Well, then we drill out the cylinder. So we need to find the volume of the cylinder. So remember that the volume of a cylinder is pi r squared h. Well, I'm thinking. It tells me, okay, it tells me the diameter. The diameter of that cylinder is 2 centimeters. So that means the radius has to be half of the diameter. So the radius will be 1 centimeter. There we go. So the volume is going to be pi times the radius squared, so 1 squared times the height. And the height of the cylinder is going to be the same as the height of the prism, which is 14 centimeters. So 1 squared is 1. So I'm going to type in my calculator, pi times 1, or you could leave the 1 off if you wanted to, times 14. So basically 14 times pi. So I'm going to use my calculator. Again, you can use 3.1 for pi if you do not have a pi key. And I'm getting that the volume of the cylinder is approximately 43.9. I'm going to round that to 44.0 because it's 43.98 on my calculator. So if I'm rounded to one place, that'll go to 0 and the whole number bumps up. So that's approximately 44 cubic centimeters for the cylinder. Well, I want to know what the volume of the prism is now after I take out that cylinder. So my total volume is going to be 175 minus 44. Use my calculator, and I'm getting that equals 131 cubic centimeters. So again, just to recap what we did, we found the volume of the original triangular prism, then we found the volume of the cylinder, and then we found the difference in those two by subtracting. All right. Next thing is a pyramid. And the volume of a pyramid is 1/3 times the base times the height. Now the base is the area of the base, which is going to be a rectangle in this one. Okay, so let's find that first, big B. So in case you don't know where I'm at, I'm on page 8 in the packet. I'm doing number 1 on page 8. So the area of the rectangle of the base is 10 times 11, length times width. And 10 times 11 is 110 square inches. So the volume is 1/3 times the area of the base times the height. So 1/3. The area of my base is 110. The height of my pyramid is this length right here, which is 16 inches. So I use my calculator. I type in 1/3. So you can do 1 divided by 3 in parentheses times 110 times 16. And I'm going to round that. Volume is approximately 586.7 because it's 0.6 repeating cubic inches. So that's how you find the volume of a pyramid. You do 1/3 times the area of the base, whatever shape the base is, and times the height. All right. Then we're going to keep on going on to the next page. So now we're on page 9 in our packet. And on page 9, we're going to do a cone. And I believe this will be our last example. Yes. So we're going to find the volume of a cone. Remember that a cone has a circle for the base. So that's where we're going to see that pi r squared in our formula. So anything with a circle base is going to have that pi r squared in it usually. And the radius of that circle is given. Remember, if they give us the diameter, like they do on number 8 right here, we would half it and get the radius. So half of 5 would be 2.5 for the radius. But on number 7, they actually gave us the actual radius. So we are ready to plug that into our formula. B equals 1/3 times pi times r squared. So my radius is 9. So 9 squared times the height, which is 17. So my volume equals 1/3 times pi times 9 squared is 81 times 17. So you always want to do your exponent before you multiply. So I'm going to multiply, first of all, I'm going to divide 81 by 3 to get 1/3 of 81. That'll help me. So 1/3 times 81 is 27. So that's just going to be less numbers I have to type in. So anytime you can do that with a fraction, that's usually easier. So 27 times 17 times 5. And again, if you don't have a pi key, you can use 3.14 since we're going to have to round anyway. So I'm going to have 1,441. It says 0.99, so I'm going to round up to 2.0. And that's going to be cubic yards. Okay. So I have shown you an example of all the figures. Now your practice will be to go to those volume and surface area reviews from page 10 and page 11. I want you to do the odd problems, which are finding the volume. I'll show you. I think I've got it somewhere. Yeah. So now you're going to go, this is on page 10 and page 11. You're going to do the volume ones. Okay. We're going to actually go down here and we're going to omit that last one, number 13. So you can omit that one. I think we already omitted number 14. And then now you can do number 16 as well. So I will put in the assignment on Google Classroom exactly what those problem numbers are, but you're going to do the volume columns, which are the odd problems. So you're going to do problems 1 through 11 odd, and then you're going to go and do number 16. So thanks for watching. Have a good day.